Hey everybody, Mr. Judson here. So let's see, we spent a couple days solving trig equations, and so now it's time to move on to something else. And I don't know if you guys remember this, but I told you this back when school was still in session. In our unit circle, we have 5 tick marks in each quadrant. And we figured out coordinates for the middle 3. We knew in the middle it's root 2 over 2 for both x and y coordinate. You know, here it's not the halfway point, so I'd call this root 3 over 2 comma 1/2. This over here does look like the halfway point. This up here, my x coordinate would be 1/2 and then comma root 3 over 2. But we never talked about these. I told you that this would be coming later, and that day has arrived. So we want to start figuring out what the sine and cosine of either 15 degrees or pi over 12 would be, or 75 degrees, or what would this be, 5 pi over 12? Okay? Anytime we deal with these tick marks that are close to either the x or the y axis, and there's going to be 2 in every quadrant, we want to use what we're going to talk about today. Okay, so let's have a look at that. So this is called the sum and difference formulas. Today we'll take a look at sine and cosine, and tomorrow we'll do the tangent. And there's just those 3. We don't do it for cotangents, cosecants, or secants. Okay? And so the formula is this. If I have the sine of u plus or minus v. Now, u and v are just angles, right? Now, sometimes people look at this and they go, well, yeah, you just distribute this and get sine of u plus or minus sine of v. But no, you can't do that. The only time you can distribute is if you have a number or a variable. You can never distribute functions. You know, something like a natural log or a log. You can't distribute those. Those are functions. Sines and cosines and tangents. You can't distribute those because they are functions. And under normal conditions, I would go through and prove why this is true. I'm not going to do this today. I'm just going to show you the formula. You know, partly because we're not in the classroom, and you know we've got a lot of stuff we're trying to get done before our Central Washington test. And you know, I'd say if somebody wants to see the proof, just get on YouTube and type in proof for sum and difference formulas, and you'll see a video that shows how to prove it. Okay. All right. So this is equal to the sine of the first angle, which is u, times the cosine of the second angle, which is v, plus or minus, so whatever, you know, the top sign goes with the top sign here. So that means if this is positive, this is positive. And the bottom 2 go together. So if this is negative, this has to be negative. And then what you do is you swap the angles. So you'd say sine of v times cosine of u. And there it is. There's our formula for the sum and difference for the sine. For the cosine, it's a little bit different. Cosine of u plus or minus v is equal to, you would do the cosine of the first angle, cosine of the second, and then now you want the sign that's here to be opposite of what you see here. So we would say minus or plus. Okay, so the top 2 go together, bottom 2 go together. If this is negative, this one has to be positive, right? And then the sine of each of these. So sine of u times the sine of v. This is the process we have to go through every time we add or subtract 2 angles. And the reason we would want to add or subtract 2 angles is to figure out those outer tick marks, the ones that we don't know anything about yet. All right, so let's do an example of this. Let's say we've got the sine of 75 degrees. And I would look at my unit circle and I would say, okay, if I drew a unit circle and I put my 5 tick marks in here, I know that it's that angle right there. Okay? So what I want to do is I want to choose 2 angles that add up to 75, or subtract, it doesn't matter. I can add or subtract and get 75. The key is you want to make sure that one of those angles is 45 degrees. I don't care what else you use, but use 45. Okay? That's not the only way to do this, but I think if you think that way, it's what makes it the easiest. So I would look at this and say, well, let's see, this is going to be the sine of 45 degrees plus 30 degrees. And both of these are tick marks that we know something about. That's the key. I need to know something about these 2 tick marks. If I would have said 50 plus 25, well, that's not really helpful because I don't know anything about 50 degrees or 25 degrees. I do know something about 45 and 30. That's these 2 tick marks. Okay? So now using the formula up here, I would say this equals the sine of the first angle, which is 45, cosine of the second angle, which is 30, and whatever sign you see here, I want to use the same, right? Because these are oriented the same way. So plus, and then you swap the angles. Sine of 30, cosine 45 degrees. And I know the coordinates for 45 are going to be root 2 over 2, comma root 2 over 2. The coordinates for 30 degrees, that does not look like the halfway point, so that's root 3 over 2. This over here does, so that would be 1/2. All right, so the sine of 45 degrees is the y-coordinate. That's root 2 over 2. Cosine of 30 is the x-coordinate. That's root 3 over 2. Plus, sine of 30 would be 1/2. Cosine of 45 is root 2 over 2. And if I multiply these, square root of 2 times square root of 3 is the square root of 6 over 4, plus root 2 over 4. And since I have a common denominator, I will write it as the square root of 6 plus the square root of 2 all over 4. There's my answer. All right, so now just to check this, let's grab our calculator. And first of all, make sure that you are in degree mode. I'm in radians, so I'll change that over. And what I'm going to do is I'm going to do the sine of 75 degrees. You guys should do this along with me with your calculator. And so what I got for that was 0.966. And so now what I want to do is I want to put this in the calculator and see if I get that same decimal number. This is the exact answer for this question. This is our rounded decimal answer. Okay? So on the Central Washington test, if they said find the exact value of this, this is the method we would have to use. So I'm going to do the square root of 6 plus the square root of 2. I'll go ahead and hit enter to get the numerator taken care of. And now I just need to divide that by 4. And I got 0.9659, which is 0.966. Yeah, so those are equal to each other. That checks out. All right, this is the kind of answer we want to get. And just kind of as a heads up, for every single one of these outer tick marks here, it doesn't matter which quadrant you're in, you are always going to get a square root of 6, a square root of 2, and a 4 in the denominator. We're just not sure if this will be positive or negative, and same thing with this. This could be a negative square root 6 minus square root 2. It could be a negative square root 6 plus square root 2. You know, we just got to make sure those signs match up to what we're supposed to get. But every answer really should look just like this one here. All right, let me give you guys one to try. All right, so we've got our rules here. We're trying to find the cosine of 195. So first of all, I've got to come up with cosine of two angles that I'm going to add or subtract to get 195. I just want to make sure that one of them is 45 degrees. Okay, you guys go ahead and try that. All right, so I'm going to use, let's go 240 degrees minus 45 degrees, okay? Now, if you chose 150 plus 45, that's fine, don't change it. You keep on working with what you have, but I'm gonna do something different. I've got 240 minus 45, that does equal 195, okay? And so according to the formula here, I want cosine of the first times cosine of the second. So I get cosine 240 times the cosine of 45. Whatever sign I have here, I want the opposite here, right? So here if I'm subtracting two angles, okay, there's a subtraction sign, it's the bottom one, I got to use the bottom one here. So that would be plus, and then I want the sine of 240 times the sine of 45. Alright, so if I draw a unit circle, here's 45 degrees. I know that the coordinates there are going to be root 2 over 2, comma, root 2 over 2. And 240, that's in this quadrant. 240 degrees would be 30 less than 270. 270 is right here, so if I back up 30, that's this angle. So my x-coordinate looks like the halfway point. It's in negative territory, so I'd have a negative 1/2, comma, y-coordinate does not, so a negative root 3 over 2. Alright, so the cosine of 240 would be a negative 1/2. Cosine of 45 is going to be root 2 over 2 plus sine of 240, which is a negative root 3 over 2, times the sine of 45, which is root 2 over 2. I know this is really hard to read, but we know what this is supposed to say, right? If you guys have your own unit circle, you can look at that. These pens, the ink is bleeding really bad right now, and it just kind of spreads out, and I don't know how to fix that. Alright, so if I multiply these two, I get a negative root 2 over 4. Here I got positive times a negative times a positive. That'll be negative overall. And I get the square root of 6 over 4. And so that means I've got a negative root 2 minus root 6 all over 4. There's my answer. So again, remember, I said we always have a root 2 and a root 6 and a 4 on the denominator. We just got to figure out what the signs are going to be. And again, real easy to check this. If I go back and do the cosine of 195, so cosine 195, I have the same answer we got last time, except it's negative this time. So a negative 0.966. So now I'm going to do this. In parentheses, I'll do my numerator, a negative square root 2, arrow out of that, minus square root 6, arrow out of that, parenthesis to end the numerator, and then divide by 4. And I got a negative 0.9659, so a negative 0.966. Same thing. Alright, so we should do at least one of these with radians. So I've got the sine of 7 pi over 12. So remember, we could change this back to degrees and you could work your way through and that's all fine, but the only way to really feel comfortable with radians is to force ourselves to use them. And I've told you guys in calculus next year, we don't ever talk about degrees. We don't ever see a degree sign, it's only radians. So I would force myself to try and do this. So the difference here is I would think, okay, I want two angles that add up to 7 pi over 12. I just want one of them to be what? Pi over 4, right? Same as 45 degrees, right? Pi over 4 and 45 are both that middle tick mark. So I want to think of this as the sine of, what am I going to have in here? What am I going to add or subtract? Let's just make one of them pi over 4. Okay, you guys go ahead and try it. So in terms of twelfths, if I want to use pi over 4, that's 3 pi over 12, right? This would reduce down to pi over 4. And so I would think that's going to be, to get 7 pi, I want 4 pi over 12. That would work. So this would simplify down to pi over 4. This one would simplify down to pi over 3. Now if you want to, you can leave it like this. That's okay. It's not your final answer. It's only the final answer that has to be reduced. Right? But if you want to leave it like this, that's fine. So our formula for sine is the top one here. We've got sine of the first angle, which is pi over 4. Cosine of the second angle, which is pi over 3. This sign stays the same, so plus, and then swap the angles. So sine of pi over 3, cosine of pi over 4. And so now I just need to find those on the unit circle. Here's pi over 4, middle tick mark. Root 2 over 2, comma, root 2 over 2. Pi over 3 is the one right next to it. So the coordinates for that point, this looks like the halfway mark. This does not. So root 3 over 2. Now we just got to plug it in. Sine of pi over 4, that's the y coordinate, that's root 2 over 2. Cosine of pi over 3, that's 1/2. Plus the sine of pi over 3, that's root 3 over 2. And the cosine of pi over 4, that's root 2 over 2. So we go ahead and multiply those. We get square root of 2 over 4 plus, remember you got to do all your multiplication before addition. Order of operations. Root 6 over 4, and that gives me an answer of the square root of 2 plus square root 6 over 4. There's my exact answer. All right, that's it. That's what we have for today is using these two formulas. And we'll do some with degree measures, we'll do some with radians. And so this should be an assignment that we're able to do okay on. All right, so here's our assignment. We're on number C13 now. It's on page 404, and we'll do 1 to 21 odd. All right, that's it. So this is day 2 out of 3, so tomorrow will be Thursday. We'll see you guys then. Till then, stay safe. Have a good day.